Okay, so this should be the last video for this section. So we're looking at problems 40 through 43, and then 46. So let's read it. This is on page 611. In a certain state, it has been shown that only 60% of the high school graduates who are capable of college work actually enroll in colleges. Find the probability that among 9 capable high school graduates in this state, each number will enroll at college. So this is, this is one of these what we call our thing. We're calling it binomial probability. So for binomial probability, first certain number of things to happen. For example, number 40, it says exactly 4. So that means that you have to come up with a combination, a perfect combination, and it says find the probability that among 9, so that's the total sample size, that 4 will enroll in college, because 60% is the probability of success in this case equals 0.6. Success means going to college. Relative to this particular question doesn't mean that is success, but that in terms of this question, success, and this is failure. So we take the probability of success times the number of successes, which is 4. Raise that to the 4th power. Take the probability of failure, and you take that to the 9 minus 4 power, which is the 5th power. So we're talking about 40, from 40 to 40 right here. Okay, so now we just have to do the calculation. 9 things, combination of 9 things taken 4 at a time is 9 factorial over 4 factorial times 9 minus 4 factorial. Gotta get my calculator. Okay, well, actually we don't need a calculator yet because we just got to simplify it. So that's going to be 9 factorial over 4 factorial, 5 factorial. So right, the numerator is 9 times 8 times 7 times 6 times 5 factorial, all divided by 4 factorial, 5 factorial, 5 factorials. Cancel out, become 1. So that'll be 9 times 8 times 7 times 6 divided by 4 factorial, which is 4 times 3 times 2 times 1. And we can do that, simplification. So that just becomes 9 times 2 times 7. 9 times 2 times 7 is 126. So the answer here is going to be 126 times 0.6 to the 4th power times 0.4 to the 5th power, and multiply that, put that in our calculator. I get 0.167. So that's the probability of getting exactly 4 out of the 9 to attend college. If the 60% is based on a large sample. What we're doing here is we're looking at a subset of that large sample. Now the next one says from 4 through 6. So the best thing to do is to we've already gotten 4, so we just have to do 4, 5, and 4, 6, and then we can add them together. So now we need to figure out what that is. Well, we'll do that down at the bottom of the page. Then we have to do x equals 6. We have So you can see I'm increasing this to match the number, and then I'm decreasing this by 1 as I go along, because I increase this by 1, I have to decrease it by 1. They both have to add up to be 9. Okay, so what we'll do here is we'll get our answer, put it over there. First we need to do these two combination things. So I have 9 factorial over 5 factorial, 9 minus 5 factorial, which is 9 factorial over 5 factorial, 4 factorial. So anyway, that is 9 times 8 times 7 times 6 times 5 factorial divided by 5 factorial and 4 factorial. So these two cancel out. So you get 9 times 8 times 7 times 6 divided by 4 times 3 times 2 times 1. And again, this cancels out that. 8 divided by 4 is 2. So we get 9 times 2 times 7. Yeah, I get the same answer because all I've done is I had the same results. So I don't know why I did that. So that's one of the symmetric things. So this is going to be 126 times 0.6 to the 5th. Now these answers are not going to be the same because we're raising these things to a different power. And the final one is 9 things grouped 6 at a time. So that's 9 factorial over 6 factorial times 9 minus 6 factorial, which is 9 factorial over 6 factorial, 3 factorial. So we get 9 times 8 times 7 times 6 factorial divided by 6 factorial, 3 factorial. These cancel out. So you get 9 times 8 times 7 divided by 3 times 2 times 1. 9 divided by 3 is 3. 8 divided by 2 is 2. So I get 3 times 2, which is 6. 6 times 7, which is 42. So this is 42. And this should be the largest number, I think, because the average is 60%. And, well, actually, not necessarily, because we have 9 people, so this would be 66%. That would be something else. So these two should be the highest ones. Okay, so take 126 times 0.6 to the 5th power times 0.4 to the 4th power. I get 0.251. I get 42 times 0.6 to the 6th power times 0.4 to the 3rd power, and I get 0.125. Okay, so 4 through 6 is just 6. It's going to add these together, so you're going to get 0.167, which is this, plus 0.251 plus 0.125, 167 plus 0.251 plus 0.125, 0.543. And that is not the right answer. I know this is correct, so I must have made a mistake up here. So let's see if we can find it. Let me just. So one way of checking my combination numbers is to go back to chapter 10, section 4, which is the Pascal's triangle. I just have to go down to the 9th row, and you see it's 126. So that part's right. The other one's apparently 84, so I must have made a mistake when I did the second one. So let's see what I did. So that's correct. 9 times 8 times 7. Oh, so that's the problem right there. 8 divided by 2 is 4, not 2. So this becomes 84. And this, therefore, up here, where is it? This becomes 84. And so this one is doubled, so that would be 0.25. Yeah, so these are about the same probability. And I was surprised that the other one was lower, and I should have realized that the number was probably wrong. Okay, so now if you add those together, I think you get the right answer. 0.668, which I think is the right answer. So the probability of picking 4 people, 5 people, or 6 people, or picking 9 people and 4 or 5 or 6 of them have go to college. Is 0.668. Okay. Now the next one is 42, and it says all 9. So in that case, this is where x equals 9. So you have 9 things, taken 9 at a time. Probability of success is 0.6 raised to the 9th power, 0.4 raised to the 0 power. So this is to this power, and this is to the difference in these two, which is 0. This first term is 1, because anytime you take x many things x many times, if these numbers are the same, it's 1. Also, if this number is something and this is 0, it's 1. 0.4 to the 0 power is 1. So the only thing we really have to calculate is 0.6 to the 9th power, which turns out to be 0.010. So the probability of all 9 people that you pick randomly going to college, if the average is 60%, it's pretty low. It's 1 out of 100 chance. And then 43 is at least 3. So this one you can do it 2 ways. You could do 4 or 3, 4, 5, 6, 7, 8, 9. Or you can do 0, 1, 2, those 3, and then add those together and subtract from 1, which is the best way to do it. So the probability of you picking 9 people and none of them going to college is when you have x equals 0. So you have 9 things, 0 time, probability of success to the 0 power, probability of failure to the 9th power. In this case, when this is 0, the resulting combination number is 1. 0.6 to the 0 power is 1. And so all you have is 0.4 raised to the 9th power. And that turns out to be 0.000262, very small. The next one, probability of 1 person, and you have 9 taken 1 at a time, 0.6 to the 1st power, and 0.4 to the 8th power. When you have 1 as the second number in the combination description, it's just the number, the original number. Then you have 0.6 to the 1st power, and then 0.4 to the 8th power, which is 0.000. Oh, forgot to multiply all this stuff together. Okay, now I get 0.00066. So if we take that number, multiply by 0.6 and times 9, we should get a larger number than the first case. And in the final one, we actually might have to, won't be able to assume what it is. Or we could go back to Pascal's triangle, look it up. So I'm going to we've done it enough here using another way, so I'm going to take advantage. So you've got 1, 9, and then 36 is the next entry in the row. So 36. And then you just multiply by these results. 0.6 squared is 0.36. And 0.4 to the 7th power is 0.00164. Multiply those all together. 36 times 0.36 times 0.00164. That'll give you 0.02125. Okay, so to do 1, 0 through 2, you just add them up. So you'd have 0.000262. That's this one here. Then 0.00353. And then the last one is 0.02125. We'll add those three numbers together. And you get 0.0250. So at least, the probability of at least 3, which means 3 or more, is 1 minus the probability of 0, 1, 2, and 3. So we get 1 minus 0.0250, which is 0.975. So that's the probability of at least 3 of the people out of the 9 going to college. Okay, one more. 46. Rate of favorable media coverage of an incumbent president. Oh, that's interesting. During the presidential campaign, 64% of political columns in a certain group of major newspapers were favorable to the incumbent president. So our probability of success here, small p, is going to be equal to 0.64, because it's what we're looking at in the problem. You read later, it'll mention how many of them are going to be favorable to the president. So as a consequence, Q is 1 minus that, which gives us 0.36. And then we have to ask the question, what is N and what is X? Well, if a sample of 15 of these columns is selected, so N is 15 columns, what is the probability that exactly 10 of them will be favorable? So X is equal to 10. X is always less than N, so it's pretty easy to figure out what they are. So the probability of X equal 10 is going to be 15 things, take it 10 at a time. Probability of success, which is 0.6. Raised to the X power. Probability of failure to the N minus X, which is 5. These add together should give us that number. Okay, so all we have to do now, as before, we have to figure out what this combination number is. So we have 15 factorial over 10 factorial times 15 minus 10 quantity factorial. 15 minus 10 is 5. We rewrite 15 factorial as 15 times 14 times 13 times 12 times 11 times 10 factorial. Divide by 10 factorial and 5 factorial. Cancel out the 10 factorial. So we have 15 times 14 times 13 times 12 times 11 divided by 5 factorial, which is 5 times 4 times 3 times 2 times 1. And let's see if we can simplify. 5 times 3 is 15. 4 times 2 is 8, but we don't have 8. So 12 divided by 4 is 3. 14 divided by 2 is 7. So that gets rid of everything in the denominator. So what we have left are 7 times 13 times 3 times 11. 7 times 13 times 3 times 11. 3003. So now we come over here, plug that in, 3003, 0.6 to the 10th, 6, 4. Oh, I keep forgetting the 4. 0.64 to the 10th, 0.36 to the 5th power. 3003 times 0.64 to the 10th times 0.36 to the 5th. And I get 0.209. So that's the probability of getting 10 out of 15. What it is if you choose 15 people randomly, the probability that 10 of them will be favorable is 0.209. There's something else I was going to say. Think about what it was. Okay, that's it.